Suppose we have a rod with a pivot here and a force acting at right angles to the rod, which is at a distance d from the pivot. From what we discussed in the introduction, the moment of this force is going to be the magnitude of the force times the distance from the pivot. In this case, since it's pushing up here, it will turn the rod in this direction. In other words, it will turn the rod clockwise. When dealing with moments, the sense of the moment, whether it is clockwise or anti-clockwise, is important. Consider this force at an angle theta to the rod. We can resolve this force into directions parallel to and perpendicular to the rod. So we have a component in this direction, and this will be f cos theta, and a perpendicular component, and this will be f sin theta. The component in this direction has a line of action directly through the pivot. Therefore, its distance from the pivot is 0, and it has no turning effect. The other force, which is perpendicular, is at a distance d from the pivot, and therefore the moment of this force is going to be f sin theta times the distance, or d f sin theta. This force turns the rod in this direction, so it's in a clockwise sense.